Hey everyone, welcome back to my channel. Today I'm going to show you a really exciting project, a personalized newsfeed powered by AI. Instead of spending hours scrolling through articles, you can have AI prepare your news just the way you like it. Cool, right? In today's video, we'll be building an application that does that. But before we get into the tech, let's quickly understand what RSS is. Websites post content every day, but finding the latest contents sometimes is really tricky. And when we are trying to scrape these data, it gets even more trickier. This is where RSS comes in. An RSS feed is a special XML page that contains a quick snippet of everything new on the site. Not the whole content, but a quick snippet. You can think of it like a restaurant menu that has an updated list of all the new dishes. Once you look at the menu, you know what's new in there. For building this project, I've used a simple but powerful tech stack. Jupyter Notebook for data fetching and preparing the data. Google Colab will actually be used to host the AI model, and Ngrok will be used to expose the API so the app can talk to the model that has been hosted in the Google Colab. And finally, we have VS Code to put everything together into a working app. In Python, we'll be using the feedparser to read RSS feeds, newspaper to extract the full article text, TQDM for progress bars just to make things clearer when fetching multiple feeds, Streamlit to build the user-friendly app where we see the personalized feeds, and requests to send the data to the AI model and get back the results. In Colab, we first install VLLM using pip install VLLM. We also then install PyNgrok. We then add our Ngrok authentication token to use Ngrok. Then we expose the port 8000 via Ngrok. We then import the snapshot download function from the Hugging Face library. We download the Qwen3 4 billion parameter model and store it in our local path. In Colab, we then open the terminal and type in VLLM serve and the path to the model. We also pass in the max model len as 20,000 tokens since we have only limited GPU, and that's it. The VLLM server has been started and exposed via ngrok. Our LLM model is now ready to be used. First, we'll import the libraries for RSS parsing, article extraction, progress bars, and data handling. Next, I define a list of RSS feeds. We'll pull fresh stories from BBC, Reuters, The Guardian, and the New York Times. I've created a function called the get news content that takes the link of the article and uses the article class to download the data, parse it, and return back the contents from the website. Next, we iterate over the URLs, parse each RSS feed, collect the items, and store basic fields like source, title, link, and publish time. Then we pass the link to our get news content function and extract the entire news content from the link. And we store all of this in a list of dictionary, and then we'll be passing that into our data frame class and we'll be creating a data frame. Now we have a data frame that has the title, the link, the published date, the summary, and the entire news. Okay, so here I have a classification prompt that I'll be using in order to classify my data into the categories that I've actually posted over here. I'll be sending each of my summaries to my model and I'll be getting back what category it has actually been placed into. So I'll be using a strict prompt so the model just returns one clean category for each summary. Next, I've imported requests and I've stored the model URL in a model URL variable. Over here, I'll be hitting the endpoint that is v1 chat completions. So VLLM actually uses the same endpoint like OpenAI. So this will be the endpoint that we'll be hitting in order to access the model. We'll be using tqdm.pandas the helper function to use progress bars with pandas operation. And next I'll be creating a create categories function that will be taking in the data, and inside the function we'll be creating the payload which will be injecting the system prompt that I've actually created, that is the classification prompt, and we'll be passing in the data that we are actually going to be fetching from each and every row. And once we've actually created the payload, we'll be sending a post request to the model URL with the payload, and then we'll be extracting the assistance message and we'll be returning it back. Next, we'll be creating a column called as the category column. And over here, we are going to be iterating over each and every summary and we'll be hitting the model. So I'll be using the progress underscore map in order to see the progress bar. So I can actually see how many summaries has actually been completed. And then I'll be passing in my create underscore categories because that is the function I'll be using in order to generate all of the classes. So now our data frame has a new column called as category, which has the category that the AI model has placed this particular news article into. Once this is done, we are going to be saving the prepared dataset so that we can use it in our application. Now that the data is prepared and classified, let's move on to building the app. First, I import the required libraries. Streamlit is used to build the web interface. Pandas is used to load and handle the dataset. Requests allow us to send data to the AI model and get back the response. Next, I define a prompt template that will be sent to the AI model. This template tells the model to act as a newsfeed writer. The model's job is to extract major information from the news content and rewrite it based on how the user wants the news. On the app side, I first use the title using Streamlit. After category is selected, the app asks the user to type in their preference. Basically, how they like the news. For example, a user might want short summaries, detailed explanations, or casual language. This will be sent to the model along with the news articles. Once the preference is entered, the app filters the dataset so that only the articles belonging to the selected categories are used. Now comes the key part. For each article in that category, the app prepares a payload that includes the system role and the formatted prompt. This payload is sent as a post request to the model URL using the request library. The app waits for the model to summarize the article. Finally, each summarized news article is displayed inside a styled card. The card has padding, rounded corners, and a light background with a subtle shadow, making the news easy to read. The summary is formatted so that the title and content are clearly highlighted. And that's it. With just a few lines of Streamlit code, the app takes a dataset of news, filters it by category, applies user preference, and uses AI to generate a personalized feed. The result is a simple interactive web page where users can get exactly the type of news they want.